Hello everyone, I want to talk about in this call about 30 minutes. First, I want to talk about Andy's main line of business. Andy's has a powerful ISA, renamed Andy Star. It is 60 and 32-bit mixable ISA. That's Andy Star. Andy's build high performance and low power CPU Andy's core. That's Andy's core. Andy's has a easy to use software development tool and design. We also have an evaluation board include the real chip type and FPGA type. And Scroll already have many software to use such as Linux, Apple's drivers, middleware, applications, and so on. And Scroll can divide into three-level CPU. The entry-level CPU is N7, N8, and N9. Speed is around 100 MHz and can be used in MCU, Bluetooth, Wi-Fi, storage, and touch panel. The middle level CPU is N10. Speed is around 300 MHz and they can use in camcorder, DSC, DVD, and DVD. The high-end CPU is N12 and 13. Speed is around 600 MHz. They can use in networking, media center, netbook, and digital TV. And this core has these features. Compatible ISA and many configurations, and can beat competitor on performance, power consumption, and die size. Next, I will talk about Andy's core MCU-based CPU. The N705 is an ultra-low power core for MCU. It has two-stage pipelines and uses Andy Star V3M ISA. V3M ISA is for MCU. It can build the smallest core size. N705 has 60 general purpose registers. It can set at the most 4 priority level in interrupt request. 7 is a low power design. User can use standby instruction to let N7 into sleep mode. The other important feature is N7 is configurable. User can trade off between performance and area by choose which multiplier to use. The fast multiplier just need only 1 cycle latency. The small needs 70 cycle latency, but the small multiplier is small area. For debug module, N7 can choose two-wire IC interface. The two-wire IC interface is mini JTAG. Standard JTAG is 5-wire and the mini JTAG is 2-wire, so it can reduce pin count in your chip. N7 can choose at most 32 interrupt source. It means N7 has an interrupt controller inside, so you don't need an external interrupt controller. The other important configuration is instruction and data local memory. It is a SRAM interface. This interface just needs only 1 cycle to fetch instruction and access data in SRAM. So the interface can improve the performance of your system. Besides, the user can connect flash or ROM in this interface and boot up your system from this interface. The other important feature is prefetch buffer and tiny cache for slow flash memory. The prefetch buffer has 2 entry buffers. One can respond instruction to CPU, and the other can receive instruction from flash concurrently. The prefetch buffer can make N7 fetch instruction from high-speed buffer, not slow flash memory. The tiny cache is a small cache inside N7. When N7 detects the loop, N7 will catch this loop into tiny cache. Next, when N7 repeats this loop, N7 will fetch instruction from high-speed tiny cache, not slow flash memory. It can improve the flash access efficiency for loop about 40%. Both of them can improve performance and reduce power consumption. For bus interface, N7 can choose AHB Lite or APB, and can choose different clock ratio between CPU and bus. It can help a user to reduce SoC power consumption. Let's see some benchmark. N7 compared with Cortex M0 Plus. We can see core area N7 is the same as M0 Plus. For performance, N7 is better than M0 Plus about 28%. For power consumption, N7 is the same as M0. Next, I will talk about another entry-level CPU called NA01. The NA01 is an entry-level core for MCU. NA01 is based on N705, but NA01 has better performance than N705. The important difference is N8 has three-stage pipeline. The others, N8 is almost same as N7. N8 has 60 general-purpose registers, array divider. Interrupt request can program to 4 levels and support local memory. Let's see some benchmark. NA compared with Cortex-M0. For multiplier, NA provides 70 cycles, but M0 provides 32 cycles. NA has array divider, but M0 didn't support. For system interface, NA can choose AHB Lite, APB, and the instruction and the data local memory, but M0 just provides AHB Lite and without local memory support. You can see the performance. NA is better than M0 about 45%. For dynamic power, NA is smaller than M0 about 6.3%. For power efficiency, NA is better than M0 about 37.5%. Next, I will talk about another entry-level CPU called N960A. N9 is based on NA, but N9 has better performance than NA. First, N9 uses V3 and ISA. As I mentioned before, V3 and ISA can build the smallest core size. Second, N9 has 5-stage pipeline. It can improve system performance. Third, N9 has static branch prediction. It can improve the performance of branch instruction. It also supports local memory and so on, such as NA. The other difference is N9 has HB bus, but NA didn't have it. We can see the benchmark. Compare N960A with Cortex-M3. For system bus interface, N9 supports HB, APB, and instruction in the data local memory, but the Cortex-M3 just supports HB Lite. I think this is very important because HB Lite just supports only one master, but the HB interface can support multi-master. If you have applications such as DMA, the HB is better than HB Lite. We also can see performance. N9 is better than M3, about 26%. And the frequency is around 200 MHz, but M3 is just around 100 MHz. And the local area, N9 is smaller than Cortex-M3, about 60%. The power is also smaller than M3, about 54%. N9 has the best number in every benchmark. Next, I will talk about N1060A. N1060A is a power cost-efficient application processor. It is based on N9, but it can support Linux. This is because N10 has an MU and MPU. An MU is a memory management unit, and MPU is a memory protect unit. Besides, N10 has cache and the DNA. It has better performance to transfer data between CPU and memory. The others, N10 use dynamic branch prediction to replace static branch prediction. It can get more better performance of branch instruction, and it also has coprocessor interface. You can connect the floating process unit in its interface to speed up floating process. We can see the benchmark. Compare N10 with ARM9. For general purpose register, N10 has 32 registers, but ARM9 just have 60 registers. For branch prediction, N10 support dynamic branch prediction, but ARM9 didn't support branch prediction. For DMA support, N10 have a local DMA, but ARM9 didn't have DMA. For system bus, N10 can support AHB, 2AHB and AHB Lite, but N9 just support 2AHB. We can see performance. N10 is better than N9 about 50%, and then the dynamic power. N10 is smaller than N9 about 89%, and the core area. N10 is smaller than N9 about 20%. Next, I will talk about this core high-end CPU. A listed CPU is a high-end CPU N13. N13 is a high-performance multi-core application processor. It is based on N10, but it has 8-stage pipeline. It gets more better performance. N13 can set cache weight at more 34 weight. The cache weight is the key point for cache performance. N13 also can pull Linux. It also has NMU. The other is N13 has XI. It is a high-speed bus interface. It can support 32 or 64 bus widths. Let's see some benchmark of N13. We can see performance N13 is 1.69 dmIPS per MHz. The total dmIPS can up to 1284. And the core die size N13 is about 0.24 mm², and the water cache frequency N13 can up to 760 MHz, and then the dynamic power N13 is about 0.076 mW per MHz. Next, I will talk about ND-Shape platform IP. Except ND's core, ND's also has platform IP renamed AG101P. User also can license this platform to use. AG101P has Mac, USB, DMA controller, LCD controller, and so on. For low-speed peripheral IP, we have a PWM, I2C, I2S, GPIO, timer, power manager, UART, and so on. The other powerful platform is AG102P. It is more better performance than AG101P. We can look at what different from AG101P to AG102P. First, AG102P use GMAC and AG101P use 1000 MAC, and AG102P use DDR2 to replace SDRAM controller and use USB OTG, AHB to PCI bridge, so AG102P can support PCI interface. Next, I will talk about ND-Shape evaluation board. And it also has evaluation board. You can use our evaluation board ADP35 to evaluate which ND core you wanted. The ADP35 use AG101P platform. Next, I will talk about ND software development environment. First, we can talk about SOC software development flow. Basically, the software development flow is include coding, debugging, and profiling. We can do all jobs in NDesign. We can use NDesign to do all jobs. We don't need additional software tool. Now let's review NDesign. NDesign has Eclipse GUI. It is a graphical user interface. User can edit code in this GUI. NDesign has GNU C and C++ compiler. User can set compiler options and compile code in NDesign. NDesign also has Linux and RTOS libraries. User can call these libraries function in NDesign. NDesign also has debugger. User can debug code in NDesign. NDesign also has profiling analyzer, so you can profiling your code in NDesign to find out the bottleneck and optimize your code. Next, I will show you NDesign. First is core edit. In a core perspective, you can see your file structure of your project in Project Explorer view. and you can edit your code in source level view. The other is compiler setting. You can choose compiler options and compile your code. Then you can see some messages such as error, warning, and so on in console view. The other is debugger. We named the debugger perspective. User can debug functions step by step. You can see the function calling stack to let you know which function is debugging. The other is source level view to let you know which line is debugging. If you want to know the CPU status, you can see CPU register view. It will report all of CPU registers. Besides, you can see the assembly code from your C code. The other, you can monitor memory by this view. The view is very useful. It can support CPU mode and bus mode. It means you can monitor cache in CPU mode and monitor bus memory in bus mode. Next is code analysis. User can use profiling analyzer to find out the bottleneck of program and optimize your program. First, NDSI can tell user total cycles of your program. The others, if you want to know total cycles of a function, it can also tell you. Besides, you can set a start pointer and an end point, and the NDSI can tell you how many cycles between these 2 points. And if user want to trace the code, just click the line, then NDSI will jump to source code. Then you can trace the code and find out the bottleneck and optimize your program. Next, I will talk about NDSoft. Our toolchain is very stable. There are many software have been approved in NDScore, such as Linux, FreeRTOS, macOS2, and Nucleus. Even applications such as WebKey, MPlayer, eBook Reader, DPF, MP3, and so on. Next, I will talk about how to evaluate NDScore. Well, finally we introduce how to evaluate NDScore. First, as I mentioned before, user can use NDSign to evaluate which NDScore can be used to develop their products. Besides, NDS can provide a synthesis report of NDScore by using some processes such as TSMC, UNC, and SMIC. These reports are include N8, N9, N10, and N13. Thanks.